gents. Let's get started with this homework. So this is 3.1. So there'll be a video key that's going to be released for all the homework series from this point forward, because we're hoping this is maybe a better way to keep you guys on track and make sure you guys are doing your homework on time, but also hopefully get the help that you need if you're not quite getting what the homework is asking. So let's just jump right into it. So question one, we need to identify the adjacent, opposite, and hypotenuse triangles. Now this only makes sense if you identify a reference angle first. But luckily for these problems, we have kind of pre-identified a reference angle. Because remember, if you don't have a reference angle, then those terminologies don't really make any sense because they're dependent completely on the reference angle. But now that we've identified the reference angle being 24, we just now have to label these sides. And there's really one that is going to be locked into place no matter what, and that's a hypotenuse. Okay? So the hypotenuse is locatable because it's always across from the right angle. We talked about that in class. That's why it's actually the largest side, because the 90-degree angle is always the largest angle. The adjacent side is the one that's going to be touching the angle of reference. That's not the hypotenuse, so we're going to label this ADJ for adjacent. And then finally, we're going to have the opposite side, and we can tell the opposite side because it's a side that is directly across from the angle. The terminology we use there is literally opposite, and also it's one that's not touching the angle. As you see, the adjacent side actually runs directly into the angle. Okay, so it actually runs right into the angle here. That's how we know it's adjacent. We know it's not hypotenuse because it's not across the right angle, and opposite, which should be directly across. And so we can kind of repeat the same process down here. We first need to realize we have the reference angle pre-marked for us. And again, we'll start with the hypotenuse. Locating the hypotenuse is always because of the right angle, and so the hypotenuse shall be this one. Touching the angle, but not the hypotenuse, will be the adjacent side. And then opposite side will be directly across from the reference angle, not touching it. And so then we have that to be the opposite. Okay? And so these terminologies are extremely important. You've seen that in class already to help locating and creating these ratios. So please keep in mind that although this is a basic skill, it's a really, really important one. Next thing we have to do is to use our trig reference sheet to solve completely the triangles below. So this is the skill that we practiced today in class, or depending when you're getting this information or doing this homework maybe a few days ago. But in the end, the trig reference sheet just represents that triangle that you were asking for. It's the reference triangle with the acknowledgement that we don't actually need to see the triangle. We just really need the ratio. And so we're going to start these the same way we started any of these problems, which is to first to pick a reference angle. 15 is a natural choice. We could go with the other one up top, which is 75. But for our purposes, since 15 was given, and it doesn't really matter what we choose, I'm going to go ahead and just choose 15 for a reference. So the reason we do this first is because we can now identify clearly the pieces that we need to find. And so we need to find the one that's touching the 15-degree angle. So I'm going to call this A, or ADJ for adjacent. And then we also need to find the one opposite that angle. And so I'm going to call this OPP for opposite. Now we have to do, what this means is we have to solve this probably twice using trigonometry. But that's not a big deal. We just have to set this problem up a couple times and solve it. So knowing that we also have our hypotenuse of 12 as a piece of the information we have to start with, and knowing that 12 is also the hypotenuse, if we're going to solve for the adjacent first, we first need to pick a ratio, and I'm just going to pick A over H, and that's going to be referencing 15 degrees. Now this will be the same because the triangles are similar. The triangle we have in front of us and the triangle on our reference sheet as A over H for 15. Now, certainly we can see why this structure is going to help us pay off a little bit. Oops. Because now all we have to do is pull numbers off of our triangle. So the A of our actual triangle, the adjacent side, is still unknown, so I'll keep it as an unknown. But we do know our hypotenuse, that's going to be 12, and that's in reference, of course, to the 15-degree reference angle. Going to our trig sheet, which means we have to find the 15-degree angle on the left and the A over H ratio from the top. We can find the A over H ratio from your trig sheet to be 0.9659. Now to help us solve this algebraically, I'm going to go ahead and put that thing over 1 so we can do a cross multiplication. because really at this point that's all we have left to do. Setting the ratios up first, we have a nice order, helps with organization. Now we can pull the numbers off, one from the triangle we're trying to solve, the other from the trig sheet that holds those values. And doing a quick cross multiplication, we have that A is going to be the same as 11.591. Okay? And so that shall be our adjacent side. Now, comparing that to the hypotenuse, that seems to be okay. The hypotenuse is still larger, so at the adjacent side seems to make some sense. Now, to solve for the opposite side, we need to repeat this process, but we'll probably go ahead and use a different ratio. Since we're solving for hypotenuse, the opposite, we had the hypotenuse, we can use O over H this time. Still referencing 15, and that should still match the O over H. For 15, we'll pull off our reference triangle. So going to our actual triangle, the O is still unknown. I'm going to change it to OP just so I don't mistake that for a 0. The hypotenuse is still 12. And then going to our reference sheet, we look at the 15 degree on the left-hand side, the O over H ratio for the top, and we find that ratio hopefully to be 0.2588. And again, to help in our solving, I'm going to go and throw that guy over 1 so we can do a quick cross multiplication. And so after doing so, we can find our opposite side to be, let's see, 3.106, rounding to 3 decimal places. Okay, and again, doing a quick kind of check in terms of does this answer make sense, especially now given all the work that we've done so far. We find that it should, because the 15 degree angle is across from the smallest side, that's only 3.106, and the 75 degree angle is across from the larger side, 11.59. Now, if we really wanted to get into it and check our work, we could just try this in the Pythagorean theorem. So we could literally see if 11.59 squared plus 3.016 squared is equal to 12 squared. I'm doing this off screen, but we see that it actually does come up to be pretty darn close to 12 squared, which is 144, which should give us confidence that our answer is correct. And so trig is one of those things where if you just do a couple like checks as you go, you should be able to determine that your answer is correct or incorrect almost right off the bat. So we're going to see a similar thought process for this problem. First, we're going to pick a reference angle, which we'll go ahead and make that to be 60. We'll label the sides that we need to find. In this case, it looks like the opposite side and the hypotenuse. And now we'll set to start creating ratios, because again, the reference sheet contains similar triangles, and so our job is to match those ratios, because that's the whole point of similarity, is that we have things that do have the same ratio. So I'm going to solve for the opposite side first. Looks like we have an adjacent side to work with, and so this guy right here is my adjacent side. And so my first ratio shall be opposite over adjacent. We're referencing 60 degrees, and that's my actual triangle. For my reference triangle off my sheet, we'll use the same ratio, opposite over adjacent, for 60, because again, similarity guarantees that these ratios have to be the same. Now it turns into a substitution problem. I don't know my OP side, but I know my adjacent side is 40. And going to my trig sheet, I have to go on the right-hand side because the degree is 60, and then read from the bottom up. And so if I pick the OP column, the O over A column for 60 degrees, reading from the bottom up, I find that that ratio is 1.7321. Okay. Again, I'll put that over 1 to kind of aid in my algebraic solving, because now we're just going to cross multiply. And after cross multiplication, we should find that this side, the OP side, it's rounded, but it's approximately equal to 69.2820. So this number should seem okay, because again, if we look at the 60 degree angle, the OP is across from that. 60 is the next largest angle in this triangle, and so 69 should be larger than 40, or the OP side should be larger than 40, and it is. And so it seemingly is okay for now. Now we don't really know until we solve for the hypotenuse, but we'll do that next, and hopefully we'll get the hypotenuse value larger than this, because hypotenuse, of course, has to be the largest side because it's across from the largest angle. But again, if we're using the adjacent side, we can probably use a ratio like A over H. Again, we'll reference 60. And because we're dealing with similar triangles, that should be exactly equal to A over H for a 60-degree angle as well. So do a substitution off your actual triangle. The A is still 40. The hypotenuse is unknown. And now go into our trig sheet, and again, because we have a 60-degree angle, that's on the right-hand side, which means we read from the bottom up. And so A over H for 60 is going to be 0.5. Again, we'll throw that over 1 just to aid in, just to kind of aid in our cross multiplication. And so in this case, we have 0.5H is equal to 40. Then solving by dividing by 0.5, we should have H to be 80. Okay? And again, that's going to fit into our overall kind of value. If you look at the angles, the OP should be larger than 40. It is. Hypotenuse is the largest. It is. It's 80. Okay, so that's going to be part 1 of this video. I'm going to divide it into multiple parts. And so this concludes part 1. I'll see you guys in part 2.